Tunneling protocols in computer networks enable the transfer of data from one network to another, including private communications across a public network like the Internet. This process, known as encapsulation, disguises the nature of the traffic by repackaging it, often with encryption for added security. By leveraging the payload section of a packet to carry service-providing packets, tunneling protocols deviate from the standard layering models like OSI or TCP/IP when necessary. These protocols can facilitate the transmission of a foreign protocol over a network that doesn't support it, such as IPv6 over IPv4, or provide inaccessible services over underlying network services. Tunneling is also utilized to bypass firewall restrictions by encapsulating blocked protocols within unobstructed ones like HTTP. One common method involves using the HTTP connect command via an HTTP proxy to establish connections to specific server ports, typically reserved for secure HTTPS connections. However, due to security concerns, access to the connect method is often limited. Other tunneling approaches leverage various protocols such as DNS, MQTT, and SMS to circumvent network firewalls effectively. For instance, generic routing encapsulation, GRE, employs IP to transport IP packets with private addresses over the Internet via packets with public IP addresses. Additionally, the Layer 2 tunneling protocol, L2TP, facilitates frame transmission between nodes, with encryption options determined by the chosen TCP/IP protocol. Protocols like SSH enhance security by encrypting data payloads transmitted over public networks, essentially creating a virtual private network, VPN. IPsec, on the other hand, offers transport mode for end-to-end encryption and can also function in tunneling mode through a trusted security gateway. Network engineers engaging with tunneling protocols must possess a comprehensive understanding of both the payload and delivery protocol sets to navigate and optimize the network stack effectively. The common tunneling protocols include IP in IP, SIT, IPv6, GRE, OpenVPN, SSTP, IPsec, L2TP, L2TPv3, VXLAN, PPTP, PPPoE, GeneV, and WireGuard. Tunneling a TCP encapsulating payload over a TCP-based connection, known as TCP over TCP, can lead to the TCP meltdown problem, causing a loss in transmission performance, prompting VPN software to opt for simpler protocols. SSH tunnels offer local and remote port forwarding, bypassing firewalls by forwarding connections to specified addresses and ports. OpenSSH's port forwarding mitigates the TCP meltdown problem as it processes the payload directly within the tunnel's TCP connection, ensuring efficient transmission. Furthermore, SSH tunnels enable users to access remote web servers by creating SOCKS proxies, providing flexibility in connecting to various ports and servers. Additionally, recent versions of OpenSSH allow for the creation of Layer 2 or Layer 3 tunnels, establishing tune or tap virtual interfaces for network management and routing, allowing for subnetwork traffic tunneling and kernel bridge connections.